Relation. It says graph the relation, tell whether it's a function, and give the domain and range. This one fell off the graph, so your 5 kind of fell off, but that's okay. I'll make sure it doesn't tomorrow. Graphing it just means to plot the points. Plot the points on the graph, all right? Tell whether or not it's a function. Well, do any of your x values repeat? They don't, so yes, this is a function. They want the domain. The domain is all of your x values from least to greatest. They want the range. That's all of your y values from least to greatest. All right? If any of your x or y values repeat, you do not list them more than once. Not, it's a function. Your mapping diagram is your either circles or rectangles or whatever. You have one for your domain, you have one for your range. You need to label domain and range. Once again, your domain is your x from least to greatest. So I would say -1, -2, 0 here. And then your range is also from least to greatest. So I would say like -27, -8, -1, and 0. And then you're going to draw a line. So 0 went to 0, -1 went to -1, -2 went to -8, -1 went to -27. You'll notice that I have 2 lines coming off of one of my domains, which means that this is not a function. Not a function. You can still graph the relation with a mapping diagram, but it is not a function because it is not a one-to-one. Yes, there are vertical lines already on your graph here. So if one of those vertical lines crosses it more than once, it is not a function. So this first one, you can see that all of these lines cross it only one time, and there's no place on the graph I could draw another vertical line and cross it more than once. So this first one is a function. This one right here, however, you'll notice that these cross that twice. This one is not a function. So you can just look at the graph and use the vertical line test to tell whether or not it is a function. Evaluate. That means plug it in and solve. This is function notation. It does not matter what this letter is. This can be any letter to represent the function. F of x, g of x, h of x, it doesn't matter. This can be any input variable. X, y, z, doesn't matter, okay? This is the function variable. This is the input variable. Output variable, input variable. That's all that means. This is your rule. What do I want you to do with my input variable to get the output? I want you to square it and subtract 2. This guy tells you what you're inputting. You are inputting a 9, and you are giving them the output. This is the domain. They're asking for the range of this domain. So you literally just take this number and you plug it in for this variable. So my answer here for g of 9 is going to be what happens when I plug in a 9. All right, and so your answer looks like this, 81 minus 2. All right, that's all you're doing. It is simply getting you used to function notation. This is asking for what is the output, what's the output when you input a 9. All right, this says find the x-intercept, find the y-intercept, and find the slope. A couple things I want to point out here. It depends on what form the line is in. If the line is in y equals mx plus b, then your y-intercept is here, your slope is here, and your x-intercept, you have to fill in a 0 for your y and solve for your x, all right? So that is slope-intercept form. If it is in standard form, your x-intercept is going to be c divided by a. Your y-intercept is going to be c divided by b. And your slope is going to be -a over b. That's how it's always going to work out. Now here's the thing. For x-intercept, you can just plug in a 0 for y and solve. For y-intercept, you can plug in a 0 for x and solve. And for slope, you can put it in slope-intercept form if you want it in slope-intercept form. So however you want to do it, you can do it depending on the format. Now, the one they gave you right here is in neither. So you're going to either have to put it in slope-intercept, or you're just going to have to plug in your x's and y's and figure out what your slope is. But this one is not in standard form or in slope-intercept form. So you probably want to put it in one of those forms if you do it that way. All right? So like if I wanted to put it in standard form, I would move my 3 over, or I could move my y over. It doesn't matter. Negative 10 equals 3x minus 5y. That is my A. That is my B. That is my C. And you can just use this little process right here. All right? If you want it in slope-intercept form, you start with it like this, right? You can move your 10 over. 5y equals 3x plus 10. Divide by 5. Y equals 3/5 x plus 2. Okay? So you can put it in whichever form you like. It's not asking for a specific form. But depending on what form it's in, you're going to answer this question maybe differently, okay? So if it's in standard form, I would say, well, my x-intercept, well, that's going to be my C, negative 10 over my A. My y-intercept is going to be C, negative 10 over my B. And my slope is going to be negative A over B, which is positive, negative over negative, all right? If I did this way, y-intercept, well, that is just my B. That's just 2. My slope, that's easy. That's just my M. And my x-intercept, I need to plug in a 0. And you're going to have to 0, subtract 2, and multiply across. So you're going to get, that one's a little more difficult, actually, to get x-intercept, honestly, for that one. Okay? But you'll still get the same thing. You'll get negative 10/3 when you do that, okay? So you have to pay attention to what format it's in. Your x-intercept is always when your y is 0. Your y-intercept is always when your x is 0. And your slope, if you put it in slope-intercept form, it's your m. If it's in standard form, it's negative a over b, all right? So you may want to try to remember these 3 right here, because they will help you when it's in standard form. Because the next one, 12, is almost in standard form. You can just put negative 6 as your A and 3 as your B. Your A is always in front of your X. Your B is always in front of your Y. Okay? Questions on that? Okay, on this page, it is wanting us to write different forms of lines. So the first one specifically is saying to write it in slope-intercept form. So you want to make sure that you pay attention to what it's asking you and which form it wants it in. So if it says slope-intercept form, it wants it in mx plus b. They have given you the m, they have given you the x and the y. So you can use the first method here by just plugging in your y equals your m times your x plus your b. Solve for your b. So you are going to multiply negative 2 and 1/2, and then you are going to subtract your 1/2. So your b equals negative 5/2. Once you have your m, which was given to you, and your b, which you solved for, you need to put it back into your y equals mx plus b format, only filling in your m and your b. The next set of questions is again asking for slope-intercept form. So again, they're asking for y equals mx plus b. But they have not given you your slope. So you do have to solve for slope using your slope equation. So you're going to subtract your y's. That's negative 3 minus 1 over your x's. That's 2 minus a negative 5. On the top, you're going to get negative 4. On the bottom, you're going to get 7. So now you have your slope, your m, and you can choose either one of your points. So I'm going to use the first point. You can either do what we did above, and you can fill in your y, negative 3, equals m, negative 4/7 times x, which is 2 plus b. Multiply those, that's negative 8 over 7 plus b. Subtract your negative 8 over 7 over. Remember, you need a common denominator. So negative 3 over 1 is negative 21 over 7. You're actually adding this because it was already a subtraction here. So negative 21 plus 8 is a negative 13 over 7, which is your b. And then you would fill in your m and your b. Or you can do your point slope, which is y minus y1 equals m times x minus x1. For this one, y minus your y1, which was negative 3, equals m, negative 4/7, x minus your x1. So for this one, you're just going to solve for y, and you don't have to plug anything back in. Once you solve for y here, you're going to end up with the same equation. Y equals negative 4/7 x minus 13/7. This last set of questions is asking for standard form. So again, make sure you remember what form you are looking for. Standard form is ax plus by equals c. Once again, they did not give you your slope, so you have to solve for your slope. So you are going to say y minus your y's on top, subtract your x's on bottom. Negative 1 minus 2 is negative 3. Negative 1 minus a negative 2 is positive 1, so my slope here is negative 3. Now, when they ask for it in standard form, you may want to use your point slope. Sometimes it's a little bit easier than doing your slope-intercept. But either way that you do it, once again, you can get your standard form as long as you make sure that at the end of this, you put your ax and your by on one side and you put your c on the other. So if you were to do it with y equals mx plus b, once again, choose either one of your points. We'll choose the first one here. Y equals m x plus b. So I have negative 1 equals 3 plus b, subtract over, b equals negative 4, all right? So I have y equals mx minus 4, so mx plus b. Now, this is not standard form. So if you do it that way, you need to move your x over. 3x plus y equals negative 4. Or you can do slope-intercept. You can say y minus y1 equals m x minus x1. You get y plus 1 equals negative 3x minus 3. Move your 3x over. Move your 1 over. You get 3x plus y equals negative 4. So either way, you're going to get the same answer. It must be in standard form for this one. When you're doing these, you need to pay attention to two things. The first thing is, how is my answer going to be? This top one's going to be y equals mx plus b. And the second thing is it parallel or perpendicular? Okay? If it's parallel, it's going to be the same slope. If it's perpendicular, it's going to be the negative reciprocal slope. All right? So like for this one, they gave me the point, so they gave me an x and a y, and they gave me the m just by giving me this line. Okay? So I can do either process. I can use my slope-intercept, or I can use my point slope. All right? I can do either one. But your final answer, they want in slope-intercept. They gave me x, they gave me y, they gave me m. And you'll notice my final answer has 3/4 as my slope. 3/4 as my slope. You can use either method, though, to get there. You do not care at all about this 2. You only care about the slope from that line, okay? For this second one, they want it in standard form. So my final answer, and you may want to write it out when you see your instructions, your final answer needs to be in standard form. They gave me an x, they gave me a y, but now they said perpendicular. Perpendicular, okay? Now here's the problem. I'm not just going to use the 4/7. The slope of the line that I want, I'm going to switch that. I'm going to flip it. Instead of 4/7, I'm going to use 7/4. And instead of positive, which is what this is, I'm going to make it negative. And then you're going to use either process. You can either use your y equals mx plus b to start. You have to eventually put it in this form. Or I would actually recommend using this one when you have to put it in standard form. But you'll notice on your final answer, it doesn't look like it is 7/4, right? But remember, in standard form, your slope is negative a over b. My a here is 7, negative 7. My b here is 4. And so you'll see that the final answer, the slope is negative 7/4, which is the negative reciprocal of what I started with, right? And so literally from 13 all the way to 32, you are using your slope formulas, your linear equations, either your y equals mx plus b or your y minus y1 equals m times x minus x1. All the way through the rest of that test, that's what you're using, okay? If it wants slope-intercept, you can use either method to find your slope and your y-intercept and then plug in your m and b. If it wants standard, you can still use either method, but your final answer needs to be ax plus by equals c. X's and y's on the left-hand side, constants on the right-hand side. All right?